students, in this video what I am going to tell you, maybe already it is known to you, but still I think it is very interesting question, interesting topic, so I think I should cover it. So let me just tell you this statement: e to the power 0 is equal to 1. You know, all of you know this, but how it is so? Many of you know this question also, and maybe you have thought about this also. So let's see how these things come. I think this is very interesting. So first of all, it was developed like this. It is seen in various mathematical problems that same number is being repeated again and again, same number is multiplied by itself again and again, maybe 1000 times. So you can see this kind of problems. So mathematicians have thought about this, that if we can simplify this, it will be much easier to handle. So they have written like a to the power 1000. That means a is multiplied 1000 times, and it is similarly a to the power 2 means a is multiplied by itself 1 times, a into a, and then a cube means a into a into a. So this representation, these are symbols. This is a symbol that represents this, and this is a symbol that represents this. So a square means a into a cube means a into a. Now what is the meaning of a to the power 1? A into what? So a square means a will come 2 times, and in between them there will be into sign, okay, multiplication sign. And again a cube means there will be 3a and multiplication operation in between. So what is a to the power 1? A to the power 1 means a and then multiplied with what? So I think if you want to follow this trend, that it is defined like this is multiplied 2 times. A square means a is multiplied by a, or a is multiplied 2 times, or a cube means a is multiplied 3 times. That means a into a into a. Then what is a to the power 1? A is multiplied with what? So in this sense there is a problem here. A is not multiplied with anything. A to the power 1 means just a, or a to the power 0 means what? If we say the a is multiplied 0 times, what is it? What does it mean? Okay. Or a to the power half, what is the meaning of a to the power half? A multiplied by what? Okay. So how these things came, this is my question. I think that you understood what I want to say. My problem is, if we want to, you have actually given a expression like a square means a into a cube means a into a, then a to the power 1 means what into what? A into what, or what, how? And a to the power 0 means what? A into what, how? Isn't it? So these meanings, how these meanings came, first of all we have to understand it. Okay, so let's see how these things have developed. A square into a cube, if I write like this, a square is a symbol of what? A into a. So we write a into a. A square means a into a, and a cube means what? A cube means a into a into a, isn't it? This is simple. These are the symbols used for simplifying these expressions. So we have actually written its original form, what it means, and they are multiplied. And here a is any real number, okay, any real number. Since we are talking about real numbers, so let us write any real number. And now in case of any real number, this parenthesis can be eliminated. It does not change anything. So now you see that a is multiplied 1 2 3 4 5 times. So what we have started with, that we will use this symbol that if a is multiplied 3 times, then we will write 3 in the power, and if it is multiplied 2 times, then we will write 2 in the power. So it is multiplied 5 times, so we can write 5 in the power, or you can just add those powers, here 2 and here 3. So you add those powers, 2 plus 3, isn't it? So you have got actually on formula that powers are being added, isn't it? Powers are being added. And in case of general, let us take a general example. If a to the power n we write, and a to the power m we multiply these two, that means a is multiplied how many times? N times for the first number. A to the power n means a is multiplied n times, nth term, and then again multiplied by a into a, how many is? Up to nth term. Now in case of multiplication, parenthesis does not, we can change we can eliminate parenthesis for any real number, so it will go like nth term, that means here there will be a also, and then again a into a up to nth term. So how many a's are multiplied actually? 1 2 3 4 dot 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 n plus 1, n plus 2, n plus 3, and dot 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 n plus mth term, total n plus mth term. So here a into a, it goes up to, if we consider all the a's, then it goes up to m plus nth term, isn't it? So just what we have started with, this big expression can be just written like a to the power m plus n. This is very simple, you know this, that the powers are just added. Okay, and why powers are just added? Because we have actually simplified that a to the power n means this and a to the power m means this, and we are just writing, and we see that a to the power n and a to the power m means this, a to the power m plus n. So we have got a formula just from the expression. Now let's do something else, like a to the power n by a to the power m. What does it mean? Let us say that n is greater than m. Okay, so we can write a into a dot dot dot, there will be another a, and this will be nth a, okay, nth a, and by a into dot 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 into nth a. Okay, so they will just eliminate each other, that means these two will become on, and there will be some a's, all a's will cut each other, and there will be some a's left. Why? Because n is greater than m. So in the numerator you will get how many a's? You will get a into a, how many? Dot 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 n minus mth a, isn't it, term? So now this expression can be written like same, a is multiplied n minus mth term, so you just can write n minus m, a to the power n by a to the power m. Okay, so here you have got another formula. This is another formula. You are just getting this from the expression. We are just writing its original form, and we are getting this expression. We are not adding anything here. Basic mathematics, basic addition and division, basic multiplication and division. Here just we are including what this expression means. A to the power a cube means what, and a square means what. We are just including that here, and we are getting these two formulas, isn't it? Very simple. Now let us say that what let us say that n is less than m, n is less than m, okay, and we are dividing n by a to the power m. So a to the power n means a into a into a into dot 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 up to nth term, and then a to the power m means a into a into a into a dot 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 up to the nth term. Now they will cut each other, and since m is greater than n, nth term will be cut by this nth term, then there will be some other terms left. So how many a's will be left in the denominator? It will be a into a dot dot dot, it will go up to how many terms? M minus nth term. So here this expression can be written like a to the power m minus n. At the very beginning we said that this expression we are using this short form, okay, writing like that. So this is what is happening here, a to the power n by a to the power m. But if we consider that this is the general formula, okay, this is general formula for any values of n and m, then from this formula, if we use this formula, so if we consider that this formula is valid for any n and for any m, then we could just write this like a to the power n minus m. But in that case, a to the power n minus m would have been n minus m would have been a negative number. N minus m is negative number. Why? Because n is less than m. So this would have been a negative number, and you could write like minus m minus n. Now m minus n is negative number, and this would have been equal to a to the power m minus 1. So now n minus m can have any value, isn't it? Like 4, 5. This is bigger number, this is a smaller number. So a to the power any negative number, let us say negative number x, is nothing but 1 by a to the power x. Are you getting this? From where this formula comes? This formula comes because we are accepting that, let us say that this is general formula. We will use this formula generally, and what it will mean is we are getting from this expression, that then if we accept this as general formula, then a to the power x has to mean 1 by a to the power x. Okay, these languages are very important. The language that I am using is very important. So this is how we are getting a to the power minus something means 1 by a to the power that power. Okay, so this is another meaning we have got. Now what is the meaning of a to the power on? A to the power on, what does this mean? Okay, so we have got here on formula, and we have accepted that this formula is a general formula. So we will use this formula for any number, and what it will mean will be we will accept the meaning that we will get from this expression. Let us do it, then you will understand. So a to the power n by a to the power m means a to the power n minus m. Okay, means this is the formula we have got. Now if n is equal to m plus 1, then this formula will be like, we can write a to the power n minus in the place of m we write m plus 1 minus m. So what we are getting, m cancels each other, so we are getting a to the power 1. But if we write this in their original expansion, what we will get in the left side? So a to the power n by a to the power m will mean that a into a into a into up to the nth a, and in the denominator a into a into a into dot 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 up to the bar up to the mth a. Now if you cancel each other, cut each other, there will be one a left, because n is just 1 greater than m. Okay, so you will get only a. So a means, if we use this formula, you get a to the power 1, and if you use just the expansion, the meaning of what a to the power n means at the beginning, so you just get a. So a to the power a means a to the power 1, no problem. So we accept this. Okay, so this is what a to the power 1 means. That's why a to the power 1 means a. Okay, because we are accepting this formula as general formula. Okay, and so we are getting that. Now what is a to the power 0 means 1? How a to the power 0 means 1? A to the power 0 means 1 how? This formula is general formula, let us say. Okay, n minus m. Now if n is equal to m, then from this formula we get a to the power n minus n, and that means a to the power 0 in the right side. Now what is the original? If we write original in the form of original expansion, what we get in the left side? Up to the nth term, and in the denominator a into a into a into a into dot 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 up to the mth term. Now m and n is same, so they will all cancel each other and you will be getting 1. So a to the power 0 means 1. So why a to the power 0 means 1? Because we are accepting this as the general formula, that even if n and m are same, let us accept that this formula is valid for this formula is a valid formula. Okay, and whatever meaning we get from the original expansion, that will be mean by this expression. A to the power 0 will mean that, and there will be no contradiction, isn't it? So this formula will be valid for m and n, even if m and m are same. Okay, because it's what we get in original formula. We are saying a to the power 0 means that. So this is how a to the power 0 means 1. Even though it is started in the form of multiplication, but a to the power 0 does not multiply by a or something like that. Still a to the power 0 means 1. Why? Because we have accepted this formula as the general formula. I don't know how much you are understanding, even though this language is becoming little, I think, complicated. Let's try another color. Okay, which color? Okay, so here what is the meaning of a to the power half? Okay, what is the meaning of a to the power half? So actually the formula that were derived were not kind of derived, it was just seen that it is like that. If we accept this expression means that, then it comes like that. If we accept this means that, this means that, this means that, then it comes like that. So even though a square means a into a will be 2 times and there will be multiplication operation in between. A cube means a will be 3 times, and there will be multiplication operation in between. Then what is half? A to the power half. What is a to the power half? What will be multiplied by what? And is there any meaning like that for a to the power half? No. We have started from this and we have derived a formula like a to the power n into a to the power m equal to a to the power n plus m, and we have also derived a to the power n by a to the power m is equal to a to the power n minus m, and we have actually extended this formula for n less than m also. And then we are accepting that, okay, let us say that if we write any power on any number, we will accept that interpretation of that power of the number that will validate these formulas. Let me tell you, explain this, then you will understand this. A to the power half into a to the power half, if we write, we get a. That means what? A to the power half plus half. We use that, this formula will be still valid, and it will become half plus half means a to the power 1, and it means a. So we say that a to the power half will mean such a number. If we multiply a to the power half by itself, we get a. Okay, so that meaning of a to the power half we are accepting. Okay, that meaning of a to the power half we are accepting, that we are assuming that even if we multiply these two numbers, their powers will be added, and then we are giving this meaning to this expression, that this is such a number. If we multiply this number by itself, then we will get a. Or what is a to the power 2 by 7? You can think like, if we multiply this number 7 times, 2 by 7, 1 2 3 4 5 into a to the power 2 by 7 into a to the power 2 by 7, then we get a square. So a to the power 2 by 7 is such a number. That means we have to add all these things. How I got a to the power square? We just added all the 2 by 7, 2 by 7, 2 by 7, 2 by 7 plus 2 by 7, and so on. So finally you get a square. So a to the power 2 by 7 is such a number that if we multiply a to the power 2 by 7 times, we will get a square. So that meaning of this expression we are accepting. Okay, I don't know how much you have understood this, but you repeat it once again, watch this video once again, and try to understand what I want to say. Okay, I think this is little very fundamental. So if you get this, I hope this will improve your thinking about how mathematical formulas are developed. There are some starting points, then there are some generalization, and then we are actually assigning meaning to various expressions, and so on. That's how mathematics is developed. And because we are assigning this meaning, actually we can expand these formulas for various kinds of numbers and various kinds of powers, and our job is simplified very much. So this is what for this video. I'll see you in the next video, and if you are watching this video for the first time, or maybe second time or third time, and you have not still subscribed this channel, please subscribe this channel. I am going to cover entire NCERT syllabus, and I can also do various other important mathematics and physics concepts. I'll clear those also. So if you are interested, please subscribe this channel and also like this video. And if you have any comment question, you can write in the comment section. I will certainly reply to your question. Okay, so see you soon in the next video. Goodbye.